So in this video, we're going to be talking about how do you combine like terms. But before we start with that, let's talk about some definitions. So first of all, a term, what it is, it's a variable or a number. So for example, x, 5x, y, xy, even the number -3. These are all terms. So notice that there is no addition and subtraction right here. It's just multiplication. You can have division by doing like 5/3. So that is a term. 5/3 is a term. It is the 5 and the 3 are connected by division in this case. Now, like terms are terms that have the same variable and the same exponent. So for example, 5x in this case and x are like terms because they both have an x to the power of 1. Now, I could also say in its own group, I can say like x squared and 3x squared. These are like terms. Now, x squared and 3x squared are not the same terms as 5x and x because this has an exponent of 1 and this has an exponent of 2. Okay, so now an expression is going to be variables put together by addition and subtraction. So you're going to have your terms here, actually a better actual like definition of that, not variables, because you can have also constants. You can have numbers as well. So it's just terms put together by addition and subtraction. So an expression does not have an equal sign. We will get to equations later on in this unit, but for right now, what we're doing is we're simplifying our expressions. All right, so we're going to start with our first example. So here we're going to put together our like terms. So the first like terms that we have here is the x squares. So I have a -5x squared and I have a +3x squared. Notice that I like to circle in the sign so that I know what I have. So we're putting these together. So whenever I'm simplifying an expression here, I'm just adding, I'm putting them together. So signs do come important because of our integer rules. I have -5 plus 3. So in this case, I'm going to have a -2x squared because they have different signs. So 3 of these positives cancel out 3 of the negatives here, and you're left with -2. Okay, now let's go ahead and combine our y's. So I have my 1/4 y and my -y. Before I move on to like how to do this, I just want to talk about that fact that when I'm putting things together, my x squared doesn't change to an x to the 4th. The only times exponents change is when you are multiplying. So here I'm just putting them together, so you're just telling me how many you have of each. Okay, so I have 1/4 minus 1. So I would do the fraction work off to the side, which is 1/4 minus 1. Remember, I need a common denominator, so that means I need to multiply this by 4/4, and you have 1/4 minus 1, 4/4. So remember, 4/4 is the same thing as 1, so I'm just changing it to an equivalent fraction. And so 1 minus 4 here would be -3/4. And so I have -3/4 y. Okay, so now my next example here, it looks pretty long, but you want to be careful because, all right, so we're combining like terms. Is there any other a squared here that I can combine? No, so all I'm going to do is bring down this this positive 1/2 a squared. Is there another a here that I can combine? Not at all, so we're just bringing this down. Now here I just have a 1/3 by itself. This we call the constant. Whenever we have a number that's just by itself, this is a constant. So I have a positive 1/4. We need to combine it with a positive 1/4. So this is our fraction work that we've been working on. We can do that off to the side. 1/3 plus 1/4. We need a common denominator, so the least common denominator I can get here is 12. So I'm going to multiply this by 4/4. And I'm going to multiply this by 3/3. And so you're going to get 4/12 plus 3/12, which is 7/12. So my constants right here is a positive 7/12. Now I'm going to check, do I have any b squares I can put together? Well, I have a -b squared and a -7b squared, which is -8b squared. And then the last thing that I know I can put together are my b's. I have a -2b and a -5b, and so if I put that together, that's -7b. And that's it. I've combined all the like terms. Remember, you need the same variable, you need the same exponent in order to be a like term. There's nothing else I can combine, and I've simplified this expression. So that is the end of this video, and I hope that you found this very helpful.